Um, Hello guys, my name is Sebastian Aguilera. This is my session 6 project for Management 413. In this assignment, I applied modern portfolio theory to construct optimal portfolios using real market data. Um, First, I'll walk you through the code, then we'll run it together, and after that, we'll analyze the results. So let's go to the code. Okay, so let me start by explaining each step of the code. So of course, first I imported the necessary libraries, as you can see here: NumPy, Pandas, YFinance, Matplotlib, and YFinance. Um, I defined 5 assets from different categories: SPY for US stocks, EPA for international developed markets, EM for emerging markets, AGG for bonds, and GLD for gold. Um, then I downloaded 5 years of historical price data using YFinance, and I made sure to set auto adjust equal false, um, so we get the correct um, adjust close column. Um, Now for daily returns for excuse me. Now I calculated daily returns and then analyzed them to get expected returns on a covariance matrix. From there, I also computed the volatility here of each asset. Now I created the I created the 3 types of portfolios: equal weight, as you can see here in step 3, uh, minimum variance, and also max Sharpe ratio. Okay, so to visualize this, um, it's going to generate a scatter plot of 10,000 portfolios and color them by Sharpe ratio, as you can see here, the color. Um, then I highlighted the equal weight, mean variance, and the max Sharpe portfolios on the chart. And here, finally, you can see the code prints of the performance summary. Um, we're going to do a weight comparison across the different strategies. And at the end, I will include validation checks to confirm things like diversification, and total weight to make sure they add to 1. Okay, so now let's run the code together. Okay, it's taking a while. 3, 4, 5, 6. Perfect. 8 seconds to go out. All right. Okay, so first here we see the plot. Let's analyze what we got. Okay, starting with equal weight portfolio, I had a return of 8.64% and a risk of 11.21% and a Sharpe ratio of 0.59. This gives us a baseline to compare against. The minimum variance portfolio had a lower return of 6.21, also had a lower risk 8.91, and had a Sharpe of 0.47. The max Sharpe had a return of 12.99, a risk of 12.12, and a Sharpe of 0.91. Um, so here we get the weight comparison. Everything's equal 20% in the portfolio. The minimum variance for US stock is 14.2. The initial stock the is 15.1. The EM stocks is 13.4. The bonds is 41.1%, and for gold is 16.1%. The max sharp is for the max sharp for US stocks is 51.4. For index stocks is 2.2%. For EM stocks is 0.6%. For bonds is 5%, and for gold is 40.8%. So the sum here are some validation checks. The sum of the mean variance weighs 1, and the risk reduction versus equals 20.54%. So here we can see that the max sharp portfolio outperforms the equal weight. And if we go to on the graph here, we can clearly see that the blue circle equals equal weight, the green circle equals mixed variance, and the gold star equals max sharp. All the simulation portfolios are spread out around the efficient frontier, and each asset is plotted with a triangle reference. So here you can see bonds, the triangle, and yeah, this project really helped me to understand how math can help us build smarter portfolios. It was really interesting to see how small differences in weights and correlations can impact the overall risk and return. So w- now that I have a more now that I'm more informed on the topic, I would say that diversification really pays off on the long run, especially with assets that don't move together. Okay, so this was it for my session 6. I hope you guys enjoyed it, and see you in session 7.